Bismillahirrahmanirrahim. Welcome to second lecture of फिजिक्स। इस लेक्चर में हम दो टॉपिक्स को डिस्कस करेंगे, एक फील्ड ऑफ फोर्सेस और सेकंड इलेक्ट्रिक फील्ड लाइंस। फील्ड ऑफ फोर्सेस में हम तीन चीज़ों को देखेंगे, एक इलेक्ट्रिक फील्ड, दूसरा इलेक्ट्रिक फील्ड इंटेंसिटी और तीसरा इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू पॉइंट चार्ज। और इलेक्ट्रिक फील्ड लाइंस को हम डिफाइन करेंगे कि व्हाट आर इलेक्ट्रिक फील्ड लाइंस और what are the characteristics or properties of electric field lines। जैसा कि हम जानते हैं कि न्यूटन लॉ ऑफ ग्रेविटेशन हमें ग्रेविटेशनल फोर्स को कैलकुलेट करने में हेल्प करता है, जबकि कूलम लॉ हमें इलेक्ट्रिक फोर्स को कैलकुलेट करने में हेल्प करता है। लेकिन यहाँ पे दो क्वेश्चन बहुत ज़्यादा इंपॉर्टेंट हैं, हाउ दीज फोर्सेज आर ओरिजिनेटेड and how these forces can be transmitted from one mass to the other or one charge to the other. The answer of these two questions is still unknown, and we accept these forces as it is, and that is why these forces are called basic natural forces. So to explain the second question, to answer the second question, Michael Faraday, who was a scientist, gave the idea of electric field. This electric field is responsible to transmit a force from one charge to the other charge. And Michael Faraday says that charge has a space around it in which field exists, and this field exert a force on the other charge. Similarly, other charge has field around it, and that field exert a force on the first charge. So to understand this, we define the electric field. Electric field is a region or space around a charge in which forces of attraction or repulsion on the other charges is observed, is called electric field. Now, to calculate the magnitude of these forces, electric forces, we use the concept of electric field intensity and define it mathematically, and we will write its SI units. So what is electric field intensity? Electric field intensity actually force exerted by a source charge on the test charge, and that is why we say that force per unit charge. So it is a ratio of force and charge. As force is a vector quantity, so electric field is also a vector quantity, and unit of force is Newton, and the unit of charge is Coulomb, so its units becomes Newton per Coulomb. जैसा कि हमने इलेक्ट्रिक फील्ड इंटेंसिटी को डिफाइन किया कि इट इज़ अ फोर्स पर यूनिट चार्ज, and mathematically it can be written as by equation 1. Using this concept, we can calculate the electric field intensity due to point charge. For this purpose, we consider 2 point charges. One is the source charge, other is the test charge. They are separated by the distance r. When one charge exerts a force on the other, direction of force will be in one direction perpendicular to the point, and electric field is also in the direction of force, so we can write E as in the direction of force. So E is defined as force per unit charge by equation 1 as shown in the equation 1. Now we apply Coulomb's law for the charges, which is given by mathematically F is equal to 1 over 4 pi epsilon naught q naught divided by r square. Now using this equation 2, in equation 1 we get the expression for the electric field intensity. Here q naught and q naught will be cancelled. We will be remained with the expression E is equal to 1 over 4 pi epsilon naught q over r. This expression is called electric field intensity due to point charges. What are the possible short questions from the article field of forces? There are two possible short questions. One is, what is the electric field intensity, and write its SI unit. Second, the distinguish between electric field and the field intensity. जैसा कि हम जानते हैं कि इलेक्ट्रिक फील्ड का कॉन्सेप्ट माइकल फैराडे ने दिया। उस इलेक्ट्रिक फील्ड की वजह से जब भी कोई एक सोर्स चार्ज किसी भी टेस्ट चार्ज के ऊपर फोर्स लगाता है तो टेस्ट चार्ज एक डायरेक्शन में मूव करता है। अगर टेस्ट चार्ज फोर्स चार्ज पॉजिटिव है, टेस्ट चार्ज हमेशा पॉजिटिव लिया जाता है, पॉजिटिव को हमेशा ये पॉजिटिव रिपेल करेगा। जो पाथ टेस्ट चार्ज फॉलो करेगा इसको हम इलेक्ट्रिक फील्ड लाइंस ई कहेंगे। दिस इज कॉल्ड इलेक्ट्रिक फील्ड लाइन। सो this will also be the first property or characteristic of electric field lines. That is, electric field line originate from positive and end at the negative. If here is a negative charge, it will be attracted toward the negative. So electric field line always originate from the positive and end at the negative charge. Second, the tangent to the field line at any point give the direction of the electric field intensity as shown in the diagram. To find the direction of electric field intensity, we draw a tangent line. This tangent line will give us the direction of electric field intensity. The lines are closer where the field is strong. The lines are further apart where the field is weak. As we know that any charge has electric field lines away from it. If it is a source charge, then lines are close near the charge. Lines are close near the charge. So electric field intensity is high near the charge, and as we move away from the charge, electric field intensity decreases. Fourth and most important, which is also a one question in the exercise, no two lines cross each other. Never two lines cross each other. What is the reason why no two lines cross each other? It is because electric field intensity has only one direction, and if two lines cross each other, then electric field intensity will have two directions at a single point. Suppose we have a curved path and here is the direction of electric field intensity E. So electric field intensity at curved path has only one direction. If it has two directions, then it is not physically possible because electric field intensity has only one direction at one point. जो चार करेक्टरिस्टिक्स हमने इलेक्ट्रिक फील्ड लाइंस की पढ़ी हैं उनको डायग्रामेटिकली आप इस स्लाइड में देख सकते हैं। यहाँ पे ये जो सोर्स चार्ज है और यहाँ पे ये सारे के सारे टेस्ट चार्जेस रखे गए हैं। टेस्ट चार्जेस विल बी रिपेल्ड बाय दिस सोर्स चार्ज and we will generate an electric field lines around a source charge as shown in the figure B. As lines are very close near the charge, so electric field intensity is strong near the charges, strong electric field near the charges, and weak as we move away from the charge. And this will be similarly for the negative charge, field lines will be toward the negative charge. And if there are two positive charges or two negative charges, they will be repelled by the electric field line, and this point is called zero electric field point, zero field point, neutral point. So there will be no electric field at the center. And if we have a positive and a negative charge, then electric field line is originated from positive and end at the negative. We can find the direction of E at any point by drawing a tangent, and we can find the direction of E at any point near these two charges. At the last, in this slide, where electric field lines are very close at the center and are parallel to each other, so field will be very strong, and at the edges these lines will be curved, and this is an example of parallel plate capacitor.